Hello, this is Professor Bedrero, and we are going to do a quick review of where we left off with our framework for hypothesis testing. And we did a comparison, albeit an imperfect one, with the US court system. When a person is taken to court, there's a default assumption that they are not guilty, unless we have enough evidence to find them guilty. And that's exactly how we determine between these two options, is by examining the evidence. In statistics, we call the default assumption the null hypothesis, and we use the symbol H sub 0 or H naught. And the other hypothesis is called the alternate hypothesis, and he is different from the opposite of the null hypothesis. And as we noted last time, sometimes we get the correct verdict out of our jury, if, for example, a not guilty verdict when the person is not guilty, or a guilty verdict when they are guilty, but sometimes we make a mistake. We make an error. A type 1 error is coming back with a guilty verdict, when in fact the person was not guilty. And a type 2 error is calling them not guilty when in fact they are truly guilty. So we want to quantify that in statistics, and so we call the level of significance this risk of a type 1 error. And we use the symbol alpha, the same alpha that we used back in chapter 7 when we were talking about confidence level, the complement of the confidence level in the confidence interval. Okay. And last time we talked about this price of bananas problem, where we were examining the average price of bananas in the nation, and it was 62 cents per pound. We wanted to talk about what the average price is in all of central Utah. So we didn't have the time to go to all the stores, so we did a random sample of 10 stores and found that the average price of bananas from that sample was 59 cents per pound and a standard deviation of 8 cents per pound. And we want to see if the evidence tells us that the price of bananas in central Utah is lower than the national average. Okay. We had a conjecture at the beginning. It's kind of like people making a guess about the court case before they hear all the evidence. But the parameter we're dealing with here is the population mean, mu. The claim that we're putting on trial, in other words, the alternate hypothesis, is that the average price of bananas in all of central Utah is less than 62 cents per pound. Therefore, the null hypothesis would be the opposite of that, which is that it's greater than or even equal to 62 cents per pound. But in a beginning stats class, we can often just call it mu equals 62 cents. Now, based on our alternate hypothesis that mu is less than 62 cents per pound, less than is to the left on a number line, so this will be a left-tailed test. Just as a quick review, a type 1 error is concluding that concluding guilty when in fact they weren't. So a type 1 error in this situation would be coming back with a conclusion that the average price of bananas in central Utah, all of central Utah, is less than 62 cents per pound, when in fact it is not. A type 2 error is failing to reject the null hypothesis, in other words, concluding the null hypothesis, when in fact it is false. So a type 2 error would be concluding that the average price of bananas is not less than 62 cents per pound in central Utah, when in fact it is. And as we saw with our mind map, we are doing a hypothesis test, okay? And we're dealing with the population mean. We had a standard deviation, but it was a sample standard deviation. The population standard deviation of the price of bananas in Sanpete County is unknown. So we will use the t-distribution and go through our requirement check. And for the mean, the requirement check is a random sample and n is greater than or equal to 30 or normally distributed. Remember that was our good friend, the central limit here. We didn't have a sample size over 30, but we did have a sample that we believe to be normally distributed. So we're going to use the t-distribution with a sample size of 10. That tells me I have 9 degrees of freedom. And we found out with our blue t-table that the critical value using a 5% level of significance and 9 degrees of freedom, so 9 degrees of freedom and 5% in one tail, our critical value should be 1.833. Now we have to be careful here because we're dealing with the left, and so our critical value needs to be actually a negative 1.833. And if we do that, that will make this area out here be exactly 5% of the area under the curve. We're going to listen to the evidence and see where the evidence lands us. If it landed us here, we would come back with a guilty verdict, meaning we have enough evidence to conclude that the average price of bananas is less than 62 cents per pound. If we land here, we're going to come back with a not guilty verdict and say that we don't have enough evidence for a guilty verdict, so we cannot say that the average price of bananas is less than 62 cents per pound. And last time, we reminded you that for our conclusion, we will reject H naught if the test statistic is in the critical region. That's the shaded region over here. It's basically our beyond reasonable doubt. And we'll fail to reject H naught if the test statistic is not in the critical region. Again, the test statistic is the number based on sample evidence. And we'll talk about how to compute them more later, but we talked about last time, let's give it to you. Let's say that the test statistic came out to be negative 1.19. So that's our test statistic, and that would put us here, which is outside of the purple critical region. So we will fail to reject H naught, meaning we don't have enough evidence to conclude that the average price of bananas in central Utah is less than 62 cents per pound. So let me pause right there and we'll make another video for example 2.